Okay, let's look at one of the techniques that you're responsible for being able to do. You, as a student, need to be able to represent multiplication and division situations involving fractions and or decimals with models. That's 7-2A. Now, you'll probably only see one question on this regarding the star, but that's one question that you'll need to get right, and also it will help you make sense of the solutions that you'll get for fraction and decimal operations. So, I've chosen for us to walk through together a very simple, straightforward problem, 0.6 times 1.2. We can make up a storyline that would model that, but for right now we're going to stick with that. Before we get there, I would like to remind you, as I pull up the writing tool, that 0.6, as is with all decimals, we could rewrite that to 6/10. And 1.2, well, some of you might be wanting to say 1 2/10. Don't forget that that's the same as saying 12/10. And this interpretation here is going to be very helpful in a little while as we make sense of some of the solutions that you'll get. So let's go ahead and wipe this off, and we will begin. Let's look at our grid. Now I want you to see that our grid is made up of 4 large squares, and each of those squares has been subdivided into 10. It needs to be said here that each one of these is one whole. So if I were to go all the way down and include both of this whole line here, that would be 2. And likewise, if my model includes everything along this line, that would be 2. So as we look at an area model, and this goes back to your squares and square roots, this is 2 times 2, which I'm hoping you haven't forgotten that that is 2 to the second power, or 2 squared. 2 squared is 4, and voila, there are 4 squares there. So that's a little bit of review, a little bit of picking up some stuff you've done earlier, and to set the stage because of the way we model this, is that along one side of our model we will represent one number, along the other side we will represent the other. You've been doing this in class, so I'm going to try not to beleaguer this, but let's do make sure we identify a few things correctly. If I come over on this side, I'm going to make this side of the model reference 0.6, and I'll make this side of the model reference 1.2. And I'm going to use a couple different colors here as I mark some things. Oh, 0.6, that's less than 1, so we know it's going to be a little bit more than half of just one of these squares. And since these are divided into rows of 10, that would be including 2, 3, 4, 5, and I'll be careful with my highlighter there. So 6. Now I want to do the best I can to mark that. So if I'm going to model 0.6 times something, I'm going to mark my model first along that left hand side to reference what 0.6 would look like or represent. Now this freaks a few people out, so don't let it bother you. That what I'm mainly concerned about is along that side there is 0.6, and everything over is part of my modeling that, even though I've got 0.6 of one square and 0.6 of another square, and if I were to keep going, the idea is that this little designation here references 6/10 of 1. So we're going to do 1.2, and I'm going to leave that in green because I want to just kind of do this. So that would be 1, and then over a little bit would be 1.2. So let's grab a marker color that hopefully won't clash too much, and we're just going to highlight. And I'm going to highlight all of this because it models for me what 1.2 would look like if I were to do it along the top of my model. So all of this is modeling 1.2 of my model, not just of one piece. piece there. So, having done that, now I want to pay special attention to the overlap sections. And the overlap is important because that's where my solution is. So if I were to mark all of these little squares that overlap, this video might take an inordinate amount of time. So I'm going to allow you to think through. I'm going to include all of those. So how many would that be? Well, if I were to count them, or if I could do a little multiplication, 12 by 6 there. So there would be 72 of the smaller squares covered. So is that my answer? 72. Sounds good. But I've got to remember that my whole is actually broken up into 100 pieces. So when I think of 72 of those, it's really 72 hundredths of 1, which I could write as a decimal very easily, hopefully by now, into 0.72. So that's what my solution would look like. So I've modeled that for you. 0.6 times 1.2, reference here, 0.6, there 1.2. I've created my solution, 0.72. Now to interpret it just a little bit, if I look from this perspective, I've got, get my box there, I've got 1.2 groups of 0.6 of a whole. And how do I get that? Well, I've got 1.2 groups, and each of these groups is 0.6 in size. It may not surprise you, hopefully not, that if I consider that same perspective from over here, I've got how many groups? Well, it looks like I've got 6 lines, but it's really 0.6 groups of 1.2. Only just slightly different, depending on how you look at it, but it's important that you see that multiplication in both directions. Well, this has been a little longer than I anticipated. I hope it's of some benefit to you. We could stop now and think about the fact that this is also modeling 6/10 times 1 and 2/10. But we'll do that later in class, I'm sure, this year. So, again, I hope that helps. And if you have any questions, let your teacher